Today we're going to take a look at Chapter 6, Section 6, which is using systems of inequalities. So, previously what we've done here, let's take a look at our then and now slide. So, we had worked on graphing earlier in this chapter and in the last chapter, and we were working on solving linear inequalities. So, we were trying to figure out which side of the line to shade once we had that graphed on our paper. Now we're going to be looking at graphing two lines and seeing where the shading overlaps. So that's our goal for today. When we're talking about a system of inequalities, what that means is it is a set of two or more inequalities and they have the same variable. So if we're dealing with x's and y's, they have the same ones, same x, same y. And we're trying to figure out where that region overlaps, where the shading overlaps. Let's take a look at this example. This says, solve the system of inequalities by graphing. So remember your slope-intercept form first. Let's start with y equals mx plus b. Don't forget that your b value is your y-intercept and your your m value is your slope. So when you're dealing with these equations, these graphs, I know they give you a graph here, but if you had to do this yourself, looking at this first equation, can you see that the 2 is in the b place, in the position of this b? So that's our y-intercept. So we would start at our origin and go up 2. That's our point. Then our slope is 2. So from here we go up 2 over 1, because 2 is the same as 2 over 1. That's our second point. And it's positive, so we know that it was up 2 over 1, up 2 right 1. So the next thing to do is to figure out, is this a solid line or a dashed line? This symbol tells us that. So don't forget, we'll use a little space here. These guys, less than and greater than, are going to be a dashed line. Well, that was a really bad dashed line. These would tell us that it's a solid line. We'll just write the word dashed. Okay, kind of hard to read there, but these represent dashed lines and these represent solid lines because this is saying that the y is less than this, it is not equal to it, which means whatever's on the line cannot be a part of the solution. So we use a dashed line to represent anything that falls on the line is not part of the solution. Okay, so dashed line. The next thing we need to do here, now that you have this line, we have this dot here, we've learned that this is a dashed line, we need to figure out which way to shade this. So in order to do that, do a test point. So let's do test point of 0, 0. So y less than 2x plus 2. I'm going to use a little extra space here. Let's jot down y is less than 2x plus 2, right? That was our equation. 2x plus 2. So if we do a test point, we're going to test, I don't know, easiest point I want to do is 0, 0. So put a 0 in for x, put a 0 in for y. So 0 in for x and a 0 in for y. Is this a true statement? Well, 2 times 0 is 0, right? And then 0 plus 2 would give us 2. Is this a true statement? Is 0 less than 2? Yup. Yes, it is. So, since this is true, 0, 0 is part of our solution. So we need to shade the part of the line, shade the side of the graph that 0, 0 falls in. So let's go back to our graph. This was our dashed line. We're supposed to shade 0, 0 as part of our solution. That means they used yellow-ish. So what they're doing is they're saying, okay, all of this is part of our solution, that whole side of the graph. Next, let's take a look at this one. So this one's y is greater than negative x plus 3. So first of all, let's find our let's find our y-intercept. Let's use orange. So our y-intercept is this guy. It's in place of the b. I see that it's negative 3. So we're going to start here. We're going to add our origin. 1, 2, 3. That's our point. Our slope is negative 1, which means from here we go down 1, right 1, or you could go up and then left. Up 1, left 1. So downward sloping line. So that would be our point, or here. We can see because of this symbol here, it is greater than or equal to, that falls into the solid category because this is saying y is either greater than all this stuff or it could be equal to it, which means it could actually fall on the line itself. It could be equal to this value instead of just greater than or less than. So that's why the line is solid, to represent anything on the line is part of the solution. So next we need to figure out, is this going to be shaded above or below that line? So y greater than or equal to negative x minus 3. Y greater than or equal to negative x minus 3. Gosh, let's go ahead and test the same point. Let's test 0, 0. That sounds easy. So if we test 0, 0 again, we're going to do the same test. Let's plug in 0 for x, 0 for y. Is this a true statement? Well, negative times 0 is just 0. 0 minus 3. 0 minus 3 is negative 3. Is 0 greater than or equal to negative 3? Is this a true statement? Is 0 greater than negative 3? Yeah, I think so. Yes. All right, true story. Okay, since that's a true statement, that means our test point 0, 0 is part of the solution. So that means, let's go up here. I think I used blue. We're going to go a little lighter. That means, sorry, we're looking at this solid line, 0, 0 is part of the solution, so we need to shade in that part of the graph. This whole part of the graph. So now when we're supposed to say, what is our solution for this? When we graph this inequality, this system of inequalities, what is our solution? The solution is anywhere where the colors overlap. Do you see this area here? Originally it was green. That's how they got the green. Blue and yellow make green, right? So that's, this whole region here is shaded in to show that that's the overlapping place. That area is the solution for our system of equations, system of inequalities. Okay, that was a long first example. Now you try. We know that one's D. Okay, try now. So feel free to pause right here, see what you can do. You know the answer is D, but let's see if you can prove it. All right. I'm going to go ahead and talk through this one. So I had to first get these on a side by itself. Okay, well feel free to pause right here. I'm going to pause too, and I'm going to work through this one and show you what I got. Alright, here's the work that I just did for this. So when I was working for this first equation, I wanted to get y on a side by itself, so I did that. And that helped me figure out how to graph this. So now I have my y-intercept and my slope. From there, once I got, and I knew that this was a solid line, so once I did that, all the graphs matched this, so that wasn't super helpful. But then I needed to figure out, let's do a test point, 0, 0. So when I did a 0, 0 in here, I figured out 0 is, according to this, 0 greater than or equal to 4, which is false. So I figured out that with this line, we're talking this line here, it would have to be above it that's shaded because we don't want 0, 0 part of the solution. So for this line, we would be shading this area here. It looks like they're using blue, so they shaded this hole. The second equation, here's my work for that. I got y on a side by itself, it's a dashed line, and then I tested 0, 0, and it ended up being a true statement. So with this dashed line, I shaded the part that was that 0, 0 was on. So I shaded the whole top side of this line. And then the solution is the overlap, the green part here. Alright, pause if you need to take a look through my work, email if you have questions. I'm going to move on and show you another example. So sometimes you might get a solution that isn't actually overlapping. So solve the system of inequalities by graphing. I'm seeing that once you graph these, there's a gap in the middle. So because these regions have no points in common, the system of inequalities has no solution. I see that this and this does not match this. I think that's just a formatting issue when putting this into the, I don't know, the publishers of the textbook maybe had some issues with that. So this should be greater than or equal to whatever. So it'd be this one greater than or equal to, so they shaded the top side. This one's less than or equal to, so they shaded what would be the bottom side. If we flipped them horizontal, it would end up being the bottom side. Okay, let's take a look at this one. Pause right here, see what you can do. and then hit play when you're ready to see my solution for this. Okay, so looking at this one, so y is greater than 4x. I had, greater than 4x. So if you plugged in 0, 0 for this, y, so 0 is greater than 0, which would be a, let me think about this. That's equal. So that falls right on the line. Kind of makes it hard to figure out which side to graph. Well, I would say that 0 is not greater than 0, so it would be a false statement. So when you're graphing this one, 4x, it looks like it's right on the line. That makes it kind of tricky. So since 0, 0 is on the line, using 0, 0 as a test point is not going to work. You probably should choose something else. Let's choose 1, 1. That's not on this line, right? So if you tested out 1, 1, you could do like 1 greater than 4 times 1. You could do that. So then 1 greater than 4. Is that a true statement? And we would say false. So for that one, since that test point, we tested this one right here. Here. Since that's a false statement, for this line here, we would shade the opposite side of that. So we would shade this side, not the part with not the side with the purple dot. Then for this one, now this one you could do 0, 0. If you did 0, 0 here, you'd have 0 less than 0 less than 4 times 0 minus 3. So is 0 less than negative 3? 0 less than negative 3. False. So for this dashed line, we tested 0, 0, and it was not part of the solution, so we had to shade this side. Now I'm looking at this thinking, wait a minute, there's nothing in between, there's no overlap. That means this is our answer. So this is not N-A-U-G-H-T, and it means nothing, none, nothing in there. So we use that to represent no solution. You could just write out the words no solution, that's fine too. But if you want to use this fancy symbol that looks like a do not enter sign, that means not. There's no overlap. Okay, how about this one? So this example says, college service organization requires its members maintain at least a 3.0 and volunteer at least 10 hours a week. So we need to write inequalities and then graph them. These are super simple. Not much to these, so this is saying G is greater than, grade point average is greater than or equal to 3. Volunteer hours is greater than or equal to 10. Let's throw it on a graph. So 10 volunteer hours, we have to shade above the 10. It could include 10, so you could get in with 10. So 10 or more. Grade point average is 3 or more. So everyone in this category here, everyone in here is part of the solution. Name one possible solution. So this is saying pick your favorite point over here. They chose 3.5 for your GPA and 12 for volunteer hours. This would be one point that fits this region here. So now you try. Senior class is sponsoring a blood drive. Anyone who wishes to give blood must be at least 17 years old and weigh at least 110 pounds. Pause right here. See what you can do. See which of these matches. When I worked through this, I got A for this one. So we're saying 17 years old, so 17 and greater, so shade that part in yellow, so 17 or greater. And then we did 110 or more. So you could do something like age is greater than or equal to 17, and you could do weight is greater than or equal to 110. So you could do something like that if it asked you to write the equations. This one is very similar, so for the sake of time, I'm going to, actually I'll show you. Okay, so this one, senior class sponsoring a blood drive, so this is pretty similar to, oh, I think that's just part of the solution. Never mind, that's part of the solution. Choose one possible solution. Sorry, let me read. Choose a possible solution. So this is saying here, which one of these falls into this category? And this looks like C, 17, and 125 fits in this category. Okay, here's your homework for this section. Feel free to rewind to re-listen to anything again. Email me if you have questions, and let me know if you get stuck on any of these so I can help. Good luck.